these. Okay, recording. I heard that. Okay, great. So since this is being recorded, hi. This is a session organized by Nginx Ingress Dev channel. This, as usual, follows the Kubernetes, the CNCF code of conduct, which boils down to be excellent to one another. And since this is being recorded, be mindful of what you say because it might be available publicly online. Okay, so
who is doing the recording?
Before going in, sorry,
Me.
Who is recording?
Me, myself.
Yusuf. Okay.
Okay. So before going into like the Kubernetes side of things, just to get like a mental model of to understand like the basic design, the core design principle of Kubernetes, it's this thing called a declarative system. So what is a declarative system? We'll spend like around 2 to 3 minutes on that. And then we'll go into like the Kubernetes side of things and actually see what all of these things are. So to understand what a declarative system is, you first have something known as a system state, which is what the current view of the world is. So let's take the analogy of a thermostat, which is a very common example while trying to explain these type of things. So a thermostat, in a thermostat's example, a system state might be the current room temperature. So let's say the current room temperature is 23 degrees Celsius. That's the system state. Now you have a desired state. What is it? A desired state is where you want to be. So you can say that I want my room's temperature to be 25 degrees Celsius. And that's your desired state. And this is where you want to be. Now, the goal now is to get the system state to the desired state. That is, you want your room's temperature to be actually 25 degrees Celsius. Now, there is another component which we will refer to as the machine. Machine, what it does is it takes a command and it acts on the command and it changes the system state. But how does it change the system state? It can't just randomly change the system state saying that I will once decide it can go higher or once randomly decide it will go lower. The goal of the machine is to execute the command that will make the system state go to the desired state as close to the desired state as possible. So it can be like the command can be like increase temperature by 2 degrees Celsius so that 23 becomes closer to 25, or increase by 1 degree Celsius so that 24 becomes closer to 25. And you're trying to get to where you want to be. The machine is what executes that command. Now, the agent is something that issues the command, meaning that going with our current analogy, an agent can be either someone like it can be a human saying that they manually go and press increase temperature like a button, or it can be like a sensor, for example, which senses that the current temperature is 23 and it says that, oh, I want to go higher. So it issues a command saying that please increase temperature by 2 degrees Celsius. So that's what an agent does. And the agent is always aware of the desired state. Now, there is another factor which comes into play, right? Which is called the environment, that is the surroundings. Now, the environment is something which you don't really have control over. And the environment also changes the system state in a way that is unpredictable and often undesirable. So let's say that you got where you wanted to be, your room's temperature is 25, but suddenly outside it starts raining and the weather becomes really cold, right? All of a sudden. And that's something that you don't really have control over. And it's something that you didn't really wish for. And also now your system state is, let's say 20 degrees Celsius or 18 degrees Celsius. And that is obviously not desired because it's not nearly equal to 25 as it was before. So that's the environment side of things. And what you want to do is you want to design a system where when you have all of these unintended state changes that happen, you want the system to be able to recover from them and eventually move in the right direction towards the desired state. So that's the environment side of things. And also another a very important point is that you have some form of feedback going from the system state to the agent, because if you don't know where you are currently and you don't know where you want to go, you can't really decide what your trajectory is going to be like. So you can't say, if you didn't know that your current temperature was 23 degrees Celsius and you didn't know your desired temperature was 25 degrees Celsius, you couldn't really issue a command saying that please increase by 2 degrees Celsius. You wouldn't have a frame of reference over there. So this pattern of getting a feedback, knowing where you want to go, knowing where you are, and then taking some action, this pattern is known as a control loop. And in this case, it's a closed feedback control loop. Now, so there are two types of design choices that you can make. One is an imperative one, another is a declarative one. An imperative one is essentially saying that the user is the one who issues a command. Now, the user can be either you as a person or someone you offload the work to, but the main idea is that there is a lot of non-automated work that happens. So there's a lot of manual work that happens here. So it's also, you can look at it as you have more attention to detail over here in an imperative system. This isn't really required. So these slides are part of like another talk, which gives some more background on what imperative and declarative is. So I'll share the link after this, but what the one key point is, in an imperative system, you have more control over what you do. But in a declarative system, you have more abstraction, meaning that if you are an end user, you have more abstraction in terms of, I don't really need to worry about all of the complicated details that something might entail. I just get like a nice tagged thing that exists that I can like refer to. Or you can even look at it like saying, let's say you wanted to go on a vacation, right? So an imperative way of doing that would be planning your itinerary, booking, like getting a visa if it's international travel, booking hotels, booking other things, and so on. So you are defining what you want to do to get to where you want to be. That is, you are defining how you want to go to your vacation. But in a narrative way of booking a vacation, what you would do is you would have your desired state, meaning that you're saying, I have this much budget, this is where my vacation destination is, and a bunch of other requirements saying that, okay, I am a vegetarian and I want vegetarian cuisine and all that. And you give all of these details to something like a travel agent. And the travel agent then does all of those things for you and you go on your vacation, right? So that's like a declarative way of doing. You have more abstraction over there. That's like a very quick difference. But in an imperative system, your agent is the user. In a declarative system, your agent is something known as a controller. Now, a controller is something that has some form of built-in logic that can decide what you want to do based on your current state and your desired state. So now if you see, the user knows the desired state. Say, now I'm the user and I say that I give to my thermostat saying that I want my room temperature to be 25 degrees Celsius. The controller can be something like a sensor with some form of logic inbuilt. And now the sensor senses that, okay, 23 degrees Celsius is the current one. I want to go to 25. So it issues a command saying that increase by 2. Now the user isn't really doing anything by going to the thermostat and increasing temperature and going back and so on. Now the user just gives the desired state to the controller and the controller does the job. And another term for control loop is reconciliation loop. And as I said, the command is something that is derived from knowing both the system state and the desired state. If you don't know both of these things, you don't really have a frame of reference here. And as I said, that's known as the feedback. I can't really do a demo because I don't have a laptop. But anyway, I know that part was a little like rust, but so far did that make sense on like an intuitive level of like how things are? Is that okay? Can someone?
That's awesome because I did not even think in these terms of introducing the concept of a controller. So that's awesome. I think that is very, very good. I think that's very
okay. So others, like if anyone has any questions or just like please speak up because I can't look at the chat right now. Or if someone can like let me know if there's anything in the chat, that'd be great.
Guys, please, this is one big request. I am convinced now that I'll do a session every day at 8 p.m. and this is one big requirement. Everybody, please unmute, please talk, because without that, it's not going to help. You know, one way it's not going to help.
Yeah. Okay. So I'm just going to take that as that was okay. But if it's not, please just like you don't have to wait for me to stop. Like just like please interrupt me. So map some of these concepts to Kubernetes. So like the machine, the desired state, system state, what is feedback, all of that, right? So in the Kubernetes side of things, the machine is something known as the API server. Now the API server is this component in Kubernetes, which is it lies in something known as the control plane. It's okay if you don't know what that means yet. And the API server is sort of the heart of the entire Kubernetes machine, right? So the machine in that mental model that we just saw is something known as the API server. And the desired state from the user's perspective is usually in terms of YAML files. So you write down in a YAML file what you want your desired state to be, saying that I want my application running in something known as pods. It's okay if you don't know what pods are. We'll come to that also. I want my application to be running in something known as pods. I want these many copies of my application running at all times. You just declare what you want to happen, and you give that to the system. And from the user's perspective, this is in terms of YAML files. From the Kubernetes, like how does Kubernetes know what the desired state is? It is stored in something known as etcd. etcd is the backing store of Kubernetes. It's on like a very high, overly simplified level, you can think of etcd as just like a key value store. Or if you're familiar with Python, you can just like, this is not right to say at all, but like, if you don't know what key value store is, you can think of like a dictionary. And like, you give it a key and you give it a value and you can look up a key and get the value, so on. The system state, on the other hand, is also, you can think of the system state to be also stored in etcd. And we'll see what that looks like and how that happens. But just for the sake of mapping these concepts to Kubernetes, you can think of the system state to be stored in etcd as well. And the feedback is gotten through something known as informers. So informers is like a broad term, but within an informer, there are other components like listers, watchers, reflectors, and things like that, but which we won't really go into detail in this session. But if you want more detail on that, we had a code walkthrough session, which I can point you to. So now finally coming to the fun part, right? How does Kubernetes do this? But before we go into how it does that, let's define a few things so to make sure everyone is on the same page. I am going to assume just one thing. I'm going to assume that people know what containers are and what they do. If anyone here doesn't know what they are or what they do, please just like speak up right now so that we can do a quick 2-minute intuitive understanding of what a container is. So if anyone, doesn't matter. It's totally okay if you don't know. Just like please let me know right now itself. Okay, so I'm assuming everyone is sort of familiar. And again, I'm sorry, I can't see the chat. So has anyone said anything in the chat? Long, can you please check?
No.
Okay, no issues. All right. Okay, so I'm assuming everyone knows what containers are. Great. So pods are the fundamental building blocks of, not building blocks of Kubernetes, but they're the fundamental units of work in Kubernetes. Meaning that if you want to run something and you want to compute something, or you want to actually say that I want to run this workload, you do it in terms of pods, not directly in terms of containers. And pod isn't actually something that runs. It's either one or more containers inside a pod that are actually run on a node. And so a very, very good way to look at a pod is looking at it by saying that a pod is a request of running a container set. When I say container set, I just mean you either specify one container that you want to run, or you specify more than one containers, whatever containers you want to run in that pod. And then a replica set ensures that a certain number of pods, a certain number of copies of pods are running at all times. And why do we need that? Why do we need replica sets? Mainly, you can think of one intuitive use case as, let's say you have a website, you deployed on Kubernetes, it becomes popular, it starts getting traffic. Now, one instance of your website isn't enough, you need more. So you say that please have 3 instances of my website and load balance among them. So that's one intuitive use case. So that ensures a certain number of copies of your pods. A deployment is a means to create and update pods in replica sets. So a deployment, you can think of the lineage as something like you have a deployment goes to a replica, not goes to, but like a deployment can be traced to a replica set. A replica set can be traced to one or more pods, and pods finally, when executed on a node, traced to the actual containers that you want running. And a node is nothing but a worker machine in Kubernetes. So you can have multiple nodes running, and you should have multiple nodes. And if you don't, then there's no valid use case for Kubernetes there. And the API server is the heart of like all of these things. So API server, if you recall, is the machine equivalent. It exposes the Kubernetes API. So all of these components that I mentioned, so the controllers that we look at now, the nodes, the components on the nodes, all of them talk to the API server. No component in Kubernetes talks to etcd. The API server exposes the state in etcd through the Kubernetes API. And coming to the fun part, the Kubernetes machine. Now, you start off with an API server, and you have a user declare their state. So you say that I want 3 replicas running at all times of this particular pod, and this is my pod template, and so on. So you specify a YAML file. It's okay if you don't understand the format of this YAML file yet. You can look it up later, or you can ask like specific things to like a deployment later on. And you declare this YAML file using some tool like kubectl, which most people have at least heard of. So kubectl apply, and you give the deployment, and that will go to the API server as your desired state now. Now you have etcd, which is the backing store and where all of the state is stored. So the API server stores your desired state. The API server stores your desired state in etcd, which is the deployment now. And now you have a bunch of controllers. So this is where controllers come in. Controllers, as depicted, you can think of it as just one loop. So you can say just like write an infinitely running for loop, which does some manipulation. Yeah.
Hello. Sorry to interrupt. Can you repeat the controller part again? Sorry to interrupt.
Which part?
The controller part.
On this slide or the previous one? Like
yeah. On this side. On this.
Yeah, sure. So as depicted, you can think of a controller for now as just like one loop, which is constantly running and checking the desired state and the current state and taking some action to make sure that the current state matches the desired state as well as possible. So there are a bunch of controllers in Kubernetes which come out of the box, but we look at 3 of these controllers today, which is the scheduler, the deployment controller, and the replica set controller. Now, most controllers come packaged in this control plane component called controller manager. The scheduler is not part of the controller manager, and the scheduler comes as an independent binary in itself. But just for the sake of simplicity, I've labeled all of these together as controllers over here. So just looking at 3 of these for now. And along with this, you have your nodes now. So these are your worker nodes. So you have node 0 and node 1. And on each node, you have the node agent, which is known as kubelet. Now, the kubelet is responsible for tasks that happen on its node, like most importantly being creation of containers, deletion of containers, and like other related things related to your containers. Now, the kubelet also is a controller in itself in terms of it checking whether whether there are pods that it should run. Now, don't worry too much about that right now. That will come like right after this. So this is what the general communication flow looks like in Kubernetes. As I said, all of these components talk to the API server, and none of them directly talk to etcd, and the API server talks to etcd, exposing the state in etcd via the Kubernetes API. Now, since there is a deployment in etcd, before that, I should probably mention what each of these controllers do in like 1 or 2 sentences. The scheduler, what it basically does is, now you have pods which you want to run, but you need to run these pods on some node, right? And now you have multiple nodes as well, but what node do you run these pods on? So the scheduler's job is to schedule some of these pods on one. It's to schedule a pod on a node. So that's the scheduler's job basically. The deployment controller's job is to manage the deployment object in etcd, or like the deployment object in Kubernetes. What it does basically is, if there is a change in the deployment, how would it react to that change? If there's a new deployment altogether, how would it react to that? If there's a deletion, how would it react to that, and so on. A replica set, on the other hand, as I mentioned, its job is to make sure that a certain number of copies of some pod is basically running at all times. Now, since there is a deployment, the deployment controller sees that there is a deployment, and it comes, it sees that there is a deployment. And since there's a deployment, and in a deployment, we said that, okay, replicas, we want 3 replicas, it creates a replica set object, and its job is done. Now the replica set controller sees that there is a replica set object, and it sees that I want 3 replicas at all times. So it will create 3 pods, each pod being the exact same one, but 3 different copies of them, basically. So the replica set controller creates these pod objects in etcd. Nothing is still actually running. It's just that these pods are created in etcd right now, and they're there. Now the replica set controller's only job was to make sure that 3 pods exist, and it has made sure that 3 pods exist. Whether it's running or not, it's not the replica set controller's job. Now the scheduler sees that there are 3 pods, but none of these pods are assigned to a node. So what the scheduler will do is, it has its own algorithm, and based on some criteria and its algorithm and a bunch of other things, it'll decide how to place a pod on a node, and it will place these pods in this manner. So like it'll say pod 0 and pod 1 go to node 0, pod 2 go to node 1. And its job is done, because the scheduler's job is to make sure that there is a node assigned to a pod, and now there is a node assigned to a pod, so its job is done. Now, a very interesting thing to note here is that not only, if you notice, deployment does not actually create a pod. A replica set creates a pod, but it doesn't schedule it. The scheduler schedules a pod, but it doesn't actually do anything to run it. So everything is very, the responsibility is very well distributed. So one nice way to think about it is, Kubernetes is not just distributing the computation among the nodes, it's also distributing the responsibility between components, so that if one of the component dies, the other components can still work fine. So now the scheduler's job is done, because it has scheduled the pods. Now the kubelets on each of the nodes sees that there are pods which are there scheduled for its node, but nothing is running on their node. So it sees that there are new pods available for me to run. So it sees that. And the moment a pod is scheduled, it becomes part of the kubelet's local desired state. When I say local desired state, it means that the kubelet knows locally that pod 0 and pod 1 on node 0 are for me, and the kubelet on node 1 says that pod 2, I am supposed to be running pod 2. And this is a new desired state for the kubelet controller. Now, if you see, the kubelet also is a control loop. So it sees that the current state, which is the system state, has nothing running. So considering node 0, there are no pods running. Pod 0 and pod 1 are not running. But the desired state is that pod 0 and pod 1 should be running. So what it will do is it will go ahead and run those pods. Now, the desired state and the current state match, meaning that its local desired state was pod 0 and pod 1. It's running pod 0 and pod 1. And on node 1, its local desired state was pod 2, and it's running pod 2. So things are working great for the kubelet and the nodes as well. Now, these pods are finally actually running. And when I say pods are running, I mean the containers that are specified under a pod template. Now, the kubelet is responsible for running these containers, and it does it through this thing called container runtime interface. I won't go into the details of that here, but it's at least good to know those terms so that you can later look it up and things like that. And things are working fine now. So initially, we gave Kubernetes our desired state, and then Kubernetes made sure that through these controllers and all of these things, it's making sure that the desired state is finally met at a later point of time. And Kubernetes always guarantees eventual consistency. Like eventual consistency is actually a very technical term which might not exactly be applied here, but the point is that your current state will eventually match your desired state. And eventually, because there can be cases where, which we will see now, there can be a case where there's a network partition between the nodes and the API server, for example, and the nodes can't communicate with the API server anymore. And there can be a case where the user comes in and says that, okay, I want 4 pods running it now, not 3. So then how would Kubernetes handle that? Which we will see a little now, like next. But let's say, as I said, Kubernetes is also distributing responsibility, right? So you have local desired states and things like that now. So now the kubelet isn't able to see what the actual desired state is, but it knows what it should be doing. So let's say pod 0, something goes wrong, right? Now the kubelet doesn't need to know what the API server or doesn't need to know what's there in etcd. It knows what pod, it knows its desired state, which is pod 0 and pod 1, but it's just doing pod 1. So what it will do is it will go ahead and rectify that and fix things to make sure pod 0 is back up and running again. So that's the benefit of like distributing responsibility as well. But the interesting thing now is that let's say there is still a network partition that is there, and the user comes and says that please scale my deployment, saying that I want 4 replicas running now instead of 3. Now, how would Kubernetes propagate this change? Let's say while the network partition is still there, the user says that please scale. Now, the API server now applies this change on the deployment. So the deployment has changed now, as you can see by this little star here. The deployment is edited saying that I need to have 4 pods in my replica set now. Now, the deployment controller sees that the deployment has been changed. And now it sees that my current state, which is 3 pods in my replica set, is not matching my new desired state, which is 4 pods in my replica set. So what I need to do is I need to edit my replica set. So it will edit the replica set. As you can see, there's a star in the replica set indicating that it has been edited. And now the deployment controller's job is done. Now the replica set controller comes online and sees that its replica set has been edited with a new desired state. So I need to have 4 now, but I have 3. So I need to create 1 more basically. So it creates another pod. Now the scheduler comes online and sees that, oh, there is a pod which isn't assigned to a node. I need to assign it to a node. So it will see that there is a pod not assigned. It will assign it now. Now, the kubelet on node 1 sees that there is a pod which is assigned to it, but not running on it. So it will go ahead and pull that new pod and make it part of its desired state, as you can see here on node 1. So pod 2 and pod 3. Now it's not running anything else. On node 1, the kubelet sees that it's just running pod 2. I need to have pod 2 and pod 3. So it will go ahead and start pod 3 as well. And now, not only did you manage to keep the system running with 3 replicas while the network partition recovered, but you also managed to propagate the new changes that the user made throughout this system by you making use of this declarative way of doing things, and by using controllers and having a desired state, having the current state, having the logic to make sure to go from the current state to the desired state, and so on. So that's your final state now, and everything is working fine. And yeah, that's all I had for like the basics part of it. So I'm hoping this gave like a good idea of what pods, deployments, and replica sets are, and most importantly, what controllers are and what they do. So I'm hoping that helped.
Oh yeah, helped a lot.
Yeah, it was great.
Guys,
Okay, so are there, like, does anyone have questions?
So with the kubelet, so the kubelet is also like acting like a controller, right?
Yeah.
Thanks.
Sure.
So every controller in scheduler, like the scheduler and the replica set, every controller keeps polling the API server for checking the etcd. So
It's
like,
not polling exactly. So polling would mean that you are constantly sending requests to see that are there any changes. But Kubernetes does things in an interesting way there by using something known as the watch mechanism. So what you can do is you can start a watch on a particular resource. Let's say you start a watch on pods, for example. And whenever a new pod is created, you get a notification from that watch saying that a new pod is created. And then you can handle that event based on your logic or whatever the controller's logic is. And this is better because you aren't constantly polling the API server. You have one connection which is established initially, and that connection remains open, receiving notifications for changes that happen on these objects, basically.
okay, thanks.
Sure.
guys, please unmute, ask questions. Without feedback, it will not move. And you won't get chances like this with Madhav being online.
Also, could you
Yeah.
repeat what you said, what the container runtime interface does?
Yeah. Sorry, I didn't get that.
Could you repeat what the container runtime interface that you mentioned does that?
Sure. So, as you may know, Kubernetes supports multiple container runtimes. When I say container runtimes, I mean the thing you use to create these containers, or so you can have different runtimes that exist. So for example, you can have container D, which is the default runtime for Kubernetes. You can have something known as Cryo. You can have something known as Rocket also. And obviously, each of these runtimes would have their different APIs for like creating containers, deleting containers, and so on. But the kubelet shouldn't really have to worry about what each of these runtimes are doing internally. So there is this component called container runtime interface, which is basically like a gRPC API that the kubelet can call into. So the kubelet just calls into the API saying that create container. And on the other hand, what the runtime is doing is it has its runtime specific implementation now. So when the kubelet calls into the API saying that create container, and let's say there's a container D runtime, the container D runtime can translate this call into container D specific instructions to create the container. Or if there's a cryo runtime, the cryo runtime can translate this request into cryo specific instructions. So the kubelet doesn't need to worry about what the runtime is. It just calls into the container runtime interface to do its bidding, basically. So that's what the CRI is.
So on a particular machine, we have a kubelet running, and then the kubelet sends a request to the runtime interface, and then it like gives a request to the particular runtime interface, which then talks to the operating system to create the container.
Yeah,
process.
exactly. Yeah, exactly. So this pattern is actually very, very common in Kubernetes. So CRI is one. There's also something known as CNI, which is container networking interface. And there's something known as container storage interface. So all of these are basically just gRPC APIs. with like other specific implementation logic hidden away, so that Kubernetes components don't really have to worry about this implementation side of things.
Yeah, I also heard that every node also has a kube proxy for network calls. I think.
Yeah. So basically, the main thing I wanted to try and get across in this session was to get an idea of what a controller is and what a controller does. So is that part, just the controller part, clear to like everyone?
Yeah.
Or
Yeah.
is there any other? I'll repeat, this is not an issue. So just let me know.
I had a doubt. Like in one of the slides, you had
Sure.
shown that the connection between the API server and the nodes were lost. Like there's an X. So how was that state recovered back? Like how did we reestablish that connection?
Sure. So that is something that Kubernetes does not do on its own. I just showed that so that to convey the point that even if that network partition or the network connection breaks temporarily, the things that are already scheduled on your nodes will continue to run without any issues, basically. And bringing that network connection back up is something that is the job of something like a cluster administrator, for example. So that's not something that Kubernetes strives to fix for you, unless you. There are weird ways to do it, but there is something known as custom resources in Kubernetes. So you can, I'm assuming, somehow define a desired state saying that I always want my connection to be running. And then you can define a custom resource saying that my desired state is always running, or always having an active connection. But if your connection breaks, you can have a custom controller saying that do some logic to make the connection come back online. But that's something, again, the user creates and does, but it's not something that Kubernetes does on its own.
Okay, yeah, thank you.
Okay, so pods, deployments, and replica sets, these are like the basic things. There are other objects in Kubernetes like jobs, services, ingress objects, which in subsequent sessions probably you can cover. But for now, I think this is like a good starting point for you. And once I'll share like the talk link also, so that you have like a end-to-end context. This was like starting from the middle. And you can also see a demo in there. So I'll share that link also. So, other than that, if like you have any other questions in general, so I can try and help on there.
Hi, Madhav. Quick question on the controllers. Those controllers like the scheduler and deployment controller and the replica set controller. Now, I believe they are all part of the what we say as master node or the master server. Can they be distributed across multiple master nodes to achieve high availability of master node itself?
Yeah, so there is something known as running the control plane in high availability mode. There is something, that configuration exists. Basically, I don't know too much about it, but I know that running it that way is possible. Yeah.
I'll cover it later if you want, because it's part of even. So every controller has to do that, become highly available. So I'll cover it later.
Cool. Now, one another probably this might have been answered somewhere else, but just like how Kubernetes support multiple container runtimes, does it also support multiple key value system like etcd? Can that be replaced with some other?
So yeah, that's a very interesting thing. So in Kubernetes, the way it's distributed, so that is like the releases that happen. You can't swap out etcd in like the way Kubernetes is, but there is another distribution of Kubernetes which is called, or not even that distribution. You can take current Kubernetes and you can like strip out a few components And there is something known as Kine, which is Kine. What that does is the API server makes the same calls that it does to Kine instead of etcd. And Kine can now translate those calls to SQL databases, for example. So it can translate those calls to MySQL or Postgres or SQLite, for example. And K3s, which is another lightweight distribution of Kubernetes meant to run on embedded devices, like Raspberry Pis or Arduinos and things like that. That uses Kine to translate those calls to SQLite, which is like a very lightweight database, which can run on things like Raspberry Pis and Arduinos. So you can swap out etcd for Kine, and my guess is that it should work fine, basically.
Okay. Thank you.
Yeah. Okay, I think if there are no other questions, we can end this session at least. And just like feel free to reach out to me on Slack also if you need any help with like just anything at all. I'd be more than happy to help out. I'm hoping this gave like a nice overview of things, and you can at least like confidently move on to services and ingress objects from like the following sessions if needed.
Yeah, no. Actually, guys, give your comment. So if you want, I'll continue and spend some time on the ingress part if you want. Otherwise, tomorrow 8 p.m. again.
I'd say like give it a like 2 days or a 1 day gap, so like people can do some research on their own if they have doubts from today's session, and then pick it up soon, so that everyone is on the same page.
Will be fine.
Okay, then let me make a few comments on a different aspect. So, who is the host now? Can you share the document that we created today, Deba? Or any one of you who is the host, can you share that document?
Yeah, Yusuf is the host, right?
Yeah, Yusuf Obush, can you share your screen and open the document?
Yeah, just give me a moment. Is it visible?
Yeah. So do those links work on top? The links on top, do they work? Just check.
Yeah.
Okay. So trying to get past this current thing that we have, that people need overview of Kubernetes as well to start contributing. From that point of view, I just put this in a certain order. Reverse proxy first. So look at that link, then Nginx itself as a web server. So you don't have to deep dive into any of this, but overview. So the problem is, if I do a demo or if I run something, it's going to be hard if you don't have a conceptual overview of these things, a reverse proxy, an Nginx, and then comes the Kubernetes, because like I was saying, the unique part of this project is that there is a Kubernetes objects component, which is written in Go, and then comes Nginx being used as for what Nginx does, basically as a web server, which is basically TCP networking, listening sockets, 8443 and all that, like a web server part, because that's where you send your traffic to. And then the reverse proxy part is that all the power of playing with the traffic, SSL certificate, load balancing, authentication. So please do have some of these things looked at, and yeah. So mother is suggesting we wait for a few days. okay, I'm on the fence on that. I don't know what to do, because I have two problems. I basically have this problem that there are some people who want to start and don't need this, and if I give them some input, they'll probably get started. So I'm very confused as to what's the right way to do these things. Madhav has done this before, so he's probably right. But that could be a long term.
So if it's something that's urgent, then sure, just do another session tomorrow. But if it's something that's not critically urgent, then even if you take about a week's time to cover these topics, it should be fine, because you would be doing it right and in a concrete manner. Okay. But on the other hand, you have better perspective from like the maintainer side of things. So if there is a lot of thing going on there, then it's totally okay to just do one tomorrow as well and record it and like let people watch it at their convenience if needed.
Okay, great. I think that input is like the critical juice which helps me decide. Yeah. So so yeah, it's going to be 8 p.m. every day, even if it is 4-5 people. And the value from that I see is we can hit the triaging part. Like I was saying, there's 250 issues, and the people who can do triaging, they're super busy. Like I said, because of the factor of 1.22 version, Kubernetes version 1.22 release coming up soon because of that. Okay, so if I can go over these fundamentals, the links that are here, right from reverse proxy to this, what's the latest news piece, and connect it to the whole goal that we have. On one part that we need contribution, the other part that people want to have that fun, excitement, and the feeling of contributing. So the whole part, I'll cover this. After doing that basic coverage, then I'll probably have to wait anyways for people to catch up and do practice on their own or try things on their own. So yeah, that's it. So tomorrow 8 p.m. again. Feel free to update this document.
Yeah, also I guess I think people need help in setting up the thing. I think like you help me in setting up the things. I think that would be also better to set up the thing so that while you are demoing, they could do it side by side and get a more good perspective about how things are working.
Yep. So what they were talking about is basically, if you guys look at these links and you say, okay, let me just try this out. What will happen is you may be able to do something, but soon you'll find that you're running out of memory and CPU. It's a very typical thing. If you all have clusters on the cloud or somewhere else, great. A virtual machine, great. But if you don't, it is an issue to have. It is an issue. So that part. So what I did was, Deva was running Windows, and I kind of talked him into, forced him into using the MX Linux distribution for less memory. So now, just even with 8 GB RAM on his laptop, he can actually reproduce issues. Actually, Deva is already underway on one PR. So he's actually able to use his less powerful laptop to create a small Minikube cluster and configure features and go with it.
Yeah, so I suggest you guys, once you look at those videos, try to replicate that in the system. And any doubt you get, you could ping me or Long regarding that. And what Long was talking yesterday about the one-to-one sessions or one-to-one help he could do. That is the best possible place where he could help you in a one-to-one in setting up, because once you play with the things, it's more easier, and the process becomes easy and fast and efficient for you. So don't just watch the videos, try playing along with it, and obviously you will stumble upon somewhere because you're starting up, and then come and ask questions, and that way the process will also be fast and it will be efficient for everyone.
Okay. Any questions?
Long, I guess just one request actually. Whenever a meeting is scheduled, or at least prior to 1 hour before, can link be posted, link or just a notification posted in channel with tagging all of us as in @ here, so that we get the notification. Sometimes in the thread we don't get the notification in apps.
Don't do here. It's not generally recommended because there are other busy people.
Okay.
Also. Yeah. So if you need to, I would suggest, like, don't post meeting scheduling messages in threads, as I said earlier. Post them on the main channel, and then like one of you can like take care of tagging like each other or something like that in like a thread of that main message, so that everyone is in the loop.
Okay. So Raj and everybody, the point I'm trying to, okay, I have, my opinion is this. I'm trying to solve two problems. So in answer to that question, I think I will, since the document format is date and topics, so my current thought is this: I'll put a date and I'll put a link there. Notification. The right way to do notifications is meeting invite through email. I'm not organized for that. So this
Okay,
document.
I guess that's fine. I mean, individually we can set a reminder for ourselves.
Yeah, my point is this: I have an intention to get kind of high level of collaboration and talking and syncing between people who can who want to do contribution here, because trust me on this, there is a very unique problem to solve. Okay, and that unique problem is you need, like I was saying, you need these 4 or 5 things together. It's not possible for one person to, the chief maintainer, he has issues on components. He like, so it's very difficult. And the way they are doing it right now, the maintainer, the top guys of the project, what they're doing is each one has specialty, and they, like, if you see the dev channel or in the either there or in their direct messages, they're coordinating that way. So it's horrible. Situation is very, very bad right now. So I'm trying, and I can assure all help. Notification, I don't know how to like organize a mailing list or all that. I don't want to go there. So if the problem we're to solve is that it's hard to get to the link, I think currently, at least for this week and next week, so it looks like I'll do every day at 8 p.m. and I'll put a date and put a link here. Then maybe after 1 week, next week, we'll find a better solution or some way to do this.
Yeah, sounds good. No worries.
Okay.
Yes,
So Raj, awesome. So I did this to Deva also. So I'm now trying to do something to you. I understand you have experience with DevOps practices, and you also said your basic awareness of Nginx, right?
Yeah.
Would you be open to helping out people who don't know anything about Nginx or reverse proxy?
I mean, my knowledge, I'm not sure if, I mean, I can definitely try to be of help, but yeah, even my knowledge is very basic. I can manage.
Whatever extent. So,
Yeah,
yesterday when we were doing, there were at least 3 people who had not used Nginx. I think even right now, guys, can you comment who has not used reverse proxy? There are 8 people now.
Yeah, I do. I just used Nginx as a website.
Okay, there you go, Raj. So you have Yusuf who has not used reverse proxy. So this is what I did yesterday and I'm doing now. I hope it is not offensive. But Yusuf, can you get with Raj and pick up whatever awareness of a reverse proxy he has got, besides the videos, I mean?
I mean, yeah. Would love to put that.
Okay, and anybody else who doesn't know what reverse proxy is, please unmute and talk.
Yeah, me.
Who?
Yeah, Anubhav.
Sorry, I didn't know.
Yeah,
okay, they have commented.
I've also like never used Nginx as reverse proxy. So I would also like to be in that session with Yusuf and Raj. So,
there you go, Raj.
Same for me. Same for me. I've also never used a reverse proxy.
Who's this? Sachin.
Sachin.
Okay. So Raj.
Even me too. Like this is Shubham. Like I just done a light reading about it, but nothing else. So Raj.
yes, I know what it means, but I've never like used it in practice, like in real world scenario. I just know what it means by watching videos and reading stuff on internet.
Yeah, so my question is, can you guys, 4 of you guys, get together and
yeah,
we can certainly do that.
Yeah, I will anyway cover it, but you know, this is what is going to really help. Probably 2 of you will work on one issue, you know, just triaging, just to reproduce. So that's why I'm saying this is going to help. So I'll tell you what I'm trying to achieve. Okay, why all this extra effort? What I'm hoping is there's enough information spread out in the community and people who are enthusiastic. The least you can do is when the issues come in, you know, 2 things. You see a new issue has come in, you go to the issue and you say, hey, I want to reproduce, or even before reproduce, first question, are you using, actually make me a host. I'll show you what problem, you know, how bad the problem is. Make me a host. I'll share my screen and show you something. Okay, can you see my screen?
Yeah.
Okay. So the issues on GitHub are one thing. Even beyond that, just in chat, today, a little while ago, you see this one, you can either open up on your computer or you can look at my screen. You see this? This user, he said, this is a feature of Ingress Nginx, okay? In simple words, we use certificates, right? SSL certificates to connect to a website. So when you if you create a website inside Kubernetes and you create an Ingress or you use Ingress to connect to the website, one option you have is, supposing you type HTTP in your browser, you don't type HTTPS, okay? Or if a client or a laptop or a cell phone makes a request, you want to make sure that all communication is only happening encrypted over HTTPS. So that is called redirect. right? It's a simple thing in web communication, right? Like if somebody requests plain text and type password, it's visible by sniffing, looking at the network packets. So you don't want to do that. So you put it and use a certificate and you encrypt it. So one of the features is that he's saying he doesn't want that, and he has explicitly configured the ingress, whatever. Don't worry about details. How we basically set the ingress controller to say, don't redirect. I'm okay with having unencrypted traffic. He said that, okay? And he's very valid. He's a experienced guy. He knows what he's doing, blah, 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 blah. Point I'm trying to make with this thread is that you see this, copy paste these commands and remember these commands. And if you can have a Minikube cluster, try to type these commands, because these commands will work with most clusters. Can each one of you please acknowledge that you see these commands and you have access?
Yeah.
Right? Okay. The crux of the matter here is, as soon as he said this and he sent me the information that I asked for, output of these commands, I opened this. And just because I've been doing this for a while, even before looking at the important, all this gibberish data that you can't make or so confusing here, the first thing I do, very first thing, I come here. Okay, there is a data that is relevant to, that says image. Okay, and it says something very specific. This name here. Okay, this name here. It's a B param for me. Just because I've repeated this for a long time. Okay, straight away I do this. So what I'm trying to say is, you don't need to know the ingress controller. You don't need to have knowledge of Golang. You don't need to know Nginx, VSOPC. If only we can get help of people asking for these commands and looking at this information and saying, hey, and what's the key takeaway here? I'll show you again. This is this. How do I minimize this thing? So this is the installation documentation of the ingress controller. One of the links is this one. Okay, I copy that. I paste it there. It's got some commands in the beginning. I remove those commands. So I actually get the manifest itself, a file. Okay, and in this file, I have the image word. I search for image word. Okay, so because I've repeated it so many times, intuitively I already know that we are on version 0.48. Are you seeing what I am trying to point at?
Right.
So by default, because of repeat, I already know 0.48 is our most recent release. And I asked him for some commands, and immediately first thing I saw is this 0.18. Right?
Yeah.
So it turns out that there is a fact about ingress controllers, that the Nginx upstream Nginx website, nginx.org.
Yeah.
So they have released, or they maintain a software, ingress controller software. Okay, they maintain an ingress controller software, fully fledged, release, its own GitHub, and everything. Okay, so what this guy said was that he used COPS. So COPS is a automation tool. script or whatever. Okay, it doesn't matter what kind of script. No? Basically, it's automation to create a cluster, ingress cluster. So if you can Google search COPS and you'll get enough information and the website and its GitHub location. So part of the documentation of this COPS automation is installation of ingress controller. Okay, so watch this conversation. I said it's not a release by this project. I told him that. Okay, and he said, I read this documentation and I ran that. Fair enough, good, right? Okay, and I told him clearly. Okay, then he said, yeah, it's not a release on this, and the release of this project is here, this location. Okay, and then see is where it finally ended. He says this one works. That is his final. That is the final conclusion. So whatever configuration of this he was trying, SSL redirect, it worked as it is without any changes. As soon as it changed to this controller. So the goal, what I want to achieve is that you may learn programming and ingress controller in your own time, but triaging, just recognizing these, talking to people who report issues, both on GitHub and in chat, and just get this. I want to achieve. I think this is very much achievable within just a couple of days. Okay. But what this requires is you should have installed the ingress controller once at least on your Minikube. Okay, and you should have executed these commands, right? And you should be able to know what to look for, which piece of information to look for in this. So this image thing is part of this command. Kube control -n kube describe pod. PO is pod. Okay. So here, see, I told him describe the pod of the ingress controller. So this is very achievable within 1 week. So if you like, you can constantly, even before learning, you can constantly start doing this. Every time somebody reports an issue, ask them for this information, verify that at least they're using this controller, verify that. So part of these commands is ask them to show their ingress. Okay, so you see here he describes his ingress. Controller. This one, this is service and describe service. Describe service. Describe service. Describe. Yeah, this one. You see this? So this is the host name. This is the backend pod to which it will connect, and other whatever attributes, doesn't matter. But describe ingress is here. This is the name of his ingress object, my HTTP. ING stands for ingress. So if you just get this command, you can, basic fundamental build of what ingress attributes are. So this is what is possible to achieve very quickly, within just a few man hours, which with the day job comes to like maybe one week of time or 4-5 days. So that is what I'm trying to achieve. And for that, please go over those links and you each. So one person can focus on service, another person can focus on ingress, and you both can chat, send the user a list of commands, and then two guys get in a chat and go over the information. One of you can evaluate the service part and tell the other person can evaluate the ingress part and tell the other, and then the user who comes in, he gets a response. And if you repeat this 10 times, you will do it in your sleep. And what that will mean is when you have to actually debug, if there's a problem and you have to debug it, you'll be able to distinguish whether it is a benign thing, which is user configuration problem, or it's a bug in the software. No, that differentiation very easily you can make. I hope that was clear. You understood, right?
Yeah. One quick question. You mentioned obviously this was from a different project, but still, is that out of generosity this help was supported, or could that have been like, this is not the right forum kind of a response?
I don't know. That's a political question. Madhav has to help me answer that.
I guess Madhav left. But yeah.
Okay. So I do. So again, I think my take is I don't focus on that, right? That's not my focus. Whether I should not support or should support. No, the point is this channel, okay, and my awareness and my involvement so far is on this project, right? So let's go over the conversation. I said, okay, that is not this one, and he said, okay, so the COP document is wrong, he asked, right? So read this thread and probably you'll understand our take on it. So it is, we really don't have time to get political, should or should not. It's just a possibility. What if I don't know that this controller, the controller released by nginx.org, right? And I don't have access to the source code, I don't have access to documentation. It's not my focus at all. I don't know how to answer your question whether I should or should not. But on the other hand, yes, I always comment by looking at information saying it is not from this project. Okay, the controller you're using, and this is a very frequent thing. Every week, if you look at chats and issues, I have said this. I think if I open up issues, I'll go open issues and look for a similar issue. Okay, and say, look for my comments, or look for issues where I commented. You'll find issues where I've said this. This week, at least last few days, a GitHub issue came up where I said the same thing. But again, the focus is not should we not answer and all. The point is somebody has a problem, they reported it here, and this is how I triaged it. He said, is it wrong? I said, no, there are two projects. One is by nginx.org and one is BES. Then I said names are similar. That's why the problem happens often. Okay, and I have no idea because I never looked at the other project. Right? I mean, generally you can assume many things, but assumption is not right when you're actually in the dev channel and actually you're responding to external users representing the project and so on, or even if you're commenting generally. Right? And then he said, so do you mean should I delete the controller, install from corps docs and install this one? I said, if you want to discuss in this this channel, users channel, right? If you want to discuss here, yes, because I can't discuss that one in this channel, not relevant, right? And then I also told him corps users may explain what is other controller. Then he just went over. So it's up to you what your focus is. Political part, take my advice, completely, give it a wide thing. Don't, because you lose everything that you're actually spending time on. I mean, correct me if I'm wrong. One side of the story is we want to learn, we want to get experience, we want to enjoy the work. Okay. Other side of the story is somebody genuinely reported it. He probably is using it in a company, probably is using it on some, and so I don't. Okay. Any other questions? Do you want to see me type commands on a cluster? Or is it too
Yeah, I
late
guess.
already?
But let's see how many participants are there. I think less participants. Okay, so I think it's your take whether you want to go or like means go with the demo part, or we could do it or something like that.
No, but nobody's commenting. No, nobody's quiet.
Yeah, I think people in the participants now could, I guess, could take a call on this, and it would be better.
Yeah, we can have some demo.
Yeah, let's do it.
Yeah, sure.
Okay. So demo wise, my interest was, I'll tell you, somewhere else. This is my cluster. So K is an alias for kube control. Okay. So I do K create. So I get a namespace called DevOps Tracker. So K minus m get all. There is nothing, there is no object, no resource in there. So I do something like this. I use a Nginx Alpine Docker image to create a deployment. So now it created a pod, created a deployment, created a replica set. It's running. Okay. So
Just a question. The deployment and the what was the other one? Yeah, the deployment, is it the controller part, like which was shown earlier? Hello?
no, deployment is not the controller part. I'll show you controller part now.
Okay.
So on the right hand side, have any of you heard of the command helm?
Yeah.
Yeah, I have.
Okay. So I used helm as per here. Okay, this one. I use this to install the controller. Okay, and that is, I can delete it and reinstall if you want, but again, just for now, I'll just show you that it's installed like that. Okay, history of my commands. So I use the command like this. Can you see?
Yeah, can see now.
Okay, I use the command like this, and I got this. I can delete, but I want to actually cover those two CLI tools I said. That's what I was showing. Okay, so I have a file, .yaml file. Okay, And what I'm going to do with the YAML file now is send it to the API server. See, it says created. Okay. And if I do k minus n DevOps dragon get ing, it is there now. Okay. This is a description of it. Okay. So the part I wanted to show was the power. Why you use ingress is I can do DevOps dragon edit ingress, and I can TLS stands for certificates and all that, right? So I completely blow that away. That's the power I have. That's why I use ingress. If I was using AWS load balancer, GCP load balancer and all that, that is going to be a big nonsense. So I can declaratively, programmatically play with all this traffic stuff. Okay. This is the IP address of my cluster, Minikube cluster. In my Etsy host, I have a bunch of host names pointing to that IP address. I do curl connection refused. Okay, that is because the IP address that I can have configured is wrong. This is the reason why it's not working. The IP address should be 100, but it is 101 because that is the old IP address. I delete that. Hopefully, I'm hoping it will recreate. I'm waiting to see. That is what Helm chart does. Okay, it will try to resync and reconcile the state that was declared at the beginning. If it doesn't do that, I'm going to force it to do that, or I can just reboot my Minikube. Okay, not working. Minikube stop. So if this happens to you when you're trying to work with it, this as quick as this. So basically in this script, I have my Minikube start command. Over here. So just unmute and comment and tell me if you have used curl or anybody who has not used curl. And there are 4 people, 7 people here, right?
Yeah.
So 7, so excluding me 6. So who has not used curl before? Please comment here.
I guess most of us have used. Also, yesterday you displayed. So I guess most of us are well known to this.
Yeah. So please unmute and comment. Please. Has everyone used curl before?
I have used familiar.
I've also used.
Okay. So nobody who has not used curl, right? So you know how you would be able to use curl on your own, right?
Yeah.
Yeah.
Okay. So let's skip curl. The next one, anybody who has not used netcat?
I've used, but have to refer for the flags.
Okay, but you can do man and see and get to see things, right?
Yeah.
Please unmute yourself and please comment. Yeah, it's going to be this is what I promise I'll cover today, because you have to go home with something that is relevant in the terms of how soon you can like just start working on something. Anybody please who's not used netcat?
Yeah, me. I've not used netcat.
Okay, so next request. Who can somebody take a 15-minute Zoom session or chat session and help Anubhav come to terms with netcat?
Yeah, can do, but just a heads up, I'm actually in UK, so I can be helpful in UK time zone, that is post India time zone.
Sure. I think Anubhav, you can comment on that, right? What timings you can.
Yeah, we will figure out.
Sorry?
We will figure out later. Me and Raj.
Okay. Nice. Okay. Okay. So deleting did not help. So L minus ingress. W is for watching. There, you see, service got created now, and the IP address is 100. Okay, and here Helm command completed. So I just ran an upgrade. I got the service. So now if I do code 80 refused, Y refused. IP it's 100 minus. Oh, the ingress was deleted. K minus n dot striking get ing. There is no ingress. So I'll apply that ingress again. So now there's an ingress resource, and if I try curl now, something wrong. Okay, first it says redirect, and this is the redirect feature. Okay, and the reason is I have TLS configured here. See this? So this is a chance to show the power of why we use ingress. So just as I can add, I can remove, I can play with it in many ways. I remove TLS. Okay. Now it says template not available. Let's why k in win get PO. Okay, it's running. Is the host name, it must reach path 80, prefix is fine. So if I do get all, say pod is deployment, replica set, there is no service. You see that?
Yes.
As you see that?
Yeah.
Yeah.
So I hope, okay, I'm a little happy that yesterday we had the exact same problem and it kind of demonstrated how ingress works. So I have ingress, okay, and the ingress says I must have a service. So this is so basically this is demonstrating the concept of a service, okay. So there's a front end service to which it must connect, and there is no service like that. So curl is saying 503. Okay, so I run a command called expose. Okay, now if I do get all, now I have a service. Okay, and if I do a curl now, I get the Nginx page. You see that? So I think it's too late. So I'll just do the last command with curl and so k minus n dot dragon exec sti. So this is a shell inside that pod. Okay. Okay, I'm inside that pod. Okay.
Yeah.
We dump. TCP dump is not there. So apk add TCP dump. So we are resolve con. This is basically DNS problem. So now I have TCP dump command. Okay. So I'm going to run TCP dump minus VVV minus S and size of the buffer I want to see is 124 minus L, and I'll make it. If you don't know the switches, no problem. Raj or anybody knows, please help out. Otherwise, I'll help out later. Okay. So I'm running TCP dump and I do curl. So you see, I see my request. Okay. Now, why I wanted to show was yesterday there was recently an issue that they were saying complaining header is not going through. So those of you know, if you know, good. If you don't know, no problem. Just example, I'm just showing you. Okay. I say my custom header 0 value 0. This object. So what I'm basically doing is I'm with HTTP now. Guys, you understand? This command. You understand? I'm playing with HTTP now. Okay. I do this. You see this. In the TCP dump inside the pod, I can see the header. You get it? So the header I passed on curl is visible. And why this point is, if you see list of issues I responded to recently in the past 1 week, somebody had complained that his headers were not reaching the application in the pod. Okay, so this is how I did it. So this is something which is very easy for you to do, just if you get these concepts, right? Does it make sense, guys?
Yeah.
So there is a bunch of such concepts. Okay, the more CLI friendly you guys become, the more it's going to really help you. Okay, HTTP ping.
Just adding on to what Long has mentioned, guys, I guess, these commands, like where you can filter out what's happening in the network level, that would definitely help you to debug and develop whatever tools related to network. Now, since this is specific to Nginx, this will be a huge help for you guys. I mean, anyone who works on these. So TCP dump, netcat, and even there is an Wireshark CLI tool. If that's something you can use, that's also good. I mean, all this gives you a very ground level packet capture facility. So try to look into those. Just read through and try to use in your local development environment.
Okay, so this is a whole world of how people work with. So I said Nginx is involved so much. Reverse proxy concept using Nginx as a reverse proxy software is involved so much. TCP/IP, HTTP, HTTPS, gRPC, all that, and all the CLI things that you do will actually help you get faster into any of these. But my first goal is very simple. Okay, I want as many people as possible to get so familiar that when issues come in, either on the Slack or in GitHub, the least you can do is be completely confident that you have a Minikube. You can ask the user for commands. Show me your controller, show me your ingress resource, show me your application service, describe blah, 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 right? And you translate that to how you will do it in Minikube. So he will have a heavy duty Java application. You don't run a Java application on your laptop Minikube and use up memory resource. So you just use this Nginx image. But the core of the relationship between a user who reported on Slack or on GitHub issue is the config. So they're called annotations here. So it will come slowly. It will come in other future sessions. But this is where you will debug and troubleshoot. TCP dump, netcat. Okay. Now I'm going to show you another interesting tool. Okay. Have you heard of a tool called MTR before? If you've not heard, it's okay. But if you install MTR and do man MTR, you will see stuff. Okay. So I do MTR minus uppercase T for TCP minus uppercase P 80 for port. I want to do MTR to yahoo.com. See what's happening? Guess what? Okay. Guess what is happening here? Do you see? Can you make? Does it make any sense? What do you see here?
It looks like all the exchanges that are happening between your host computer and some other network, like some other website.
Yes, very true.
All the packet exchanges.
So, yeah, right. So I'll show the relevance for that here now. Okay, I'm going to do the same thing for the pod which I'm running in my cluster. Straight away it went there. Okay, why this is relevant is, let's do something smaller or shorter. Okay, all are too much. Okay, what about google.com? Okay, screw that. Let me do this. Port 53 for DNS traffic to the Google DNS server. See that? So why this tool is important is, people will say, okay, my pod is not working. I'm not able to connect from here to there. Okay, I have one front-end pod, one back-end pod, and my ingress is not allowing me to connect from front-end to back-end. You show him this MTR, or you do MTR on your thing. Basically says at each hop from the source to the destination where there is loss of the packet network traffic. Okay, make sense?
Yeah.
Yeah.
Okay.
Yeah.
So see today's chat. I think it's too late. So I mentioned a bunch of names, bunch of CLI tools.
Yeah.
So one of them is called Postman. So I did not think about it, but now I'm thinking those terms like assignment type, homework type, or whatever thing, whatever concept. The thing is, if you guys have used Postman, great. If you haven't, see if you can use Postman and compare with curl and do all the play. So read free examples of Postman and curl usage, how to put header, how to put that. That is basically a dive into HTTP and all that. Okay. So see if you guys can do that. Okay, because that will be the daily in and out usage when you're working, because everything about ingress is HTTP and HTTPS, right? 99%, right? So either you will debug in TCP dump, or you will use curl and get a response. So one of the curl things, -i, okay, is a just example. -i. I don't get the page, but I get the HTTP response. Okay, and if I add one V, verbose, I see more verbosity in the response and the request. This request is a response. Okay, if I add a second V, nothing happens, but one V maybe. So this information here is what the issues will be created on. You get it? So HTTP perf is for loading, generating load. Okay. Performance measurement. So you can continuously generate traffic with the CLI command. How this works? See, here's an example. These are kind of output you'll get. Okay. So this is what you play with. This is what I want. I'm hoping I can, get you guys all up to speed. So we are on the same page. Because if there is issue triaging, then this is what we're going to use. Right? So this is a whole world of these such things. Explore that. Okay. Catch up videos, explore that, and you'll at least be able to respond. Look up, go to issues and read up on, for 2 days maybe, read up on the issues that I have been commenting on. you'll see a constant pattern of these commands that I said,
Right.
and what the information means. So you learn Kubernetes also that way. Okay, then you look up something, you run a command, you get information back, you go to YouTube and look up a video on it, you get some picture added, and you go on. Okay, 10:09, 2 hours. So I can't thank you enough for having interest and showing showing interest in like staying up so late. So I know my only problem is the feedback is not enough for me, because I can do a lot more help than I'm doing now, and because it all comes so easy, and it's only possible if very high communication and feedback exists. I don't want to make comments on why, how. Probably you're used to more listening. Probably you're more introvert. You'd like to actually get work done instead of talking too much. Irrespective of that, I also don't like to talk. But my problem here is that we are having an engagement. We are in meetings, and the more one way it is, the less benefit that comes out of it. And the more it is you guys talking and me just answering, the faster you guys can actually get on to triaging, at least talking to users, responding to users of Ingress, and on both GitHub issues as well as Slack. And once you start with that, it's addictive, I'll tell you. It's an addiction. The fun of knowledge of learning, the deep dive into Nginx, service proxy, and then the Kubernetes component of it, it's really fun. So that's what. So once you are that fun, enjoying thing, I don't need to hold hands. I'll back off. Like I can start focusing, or rather, I don't have to spend time on these sessions and all that. Then we'll only be talking about issues and concepts. Okay. Anything else? I'm done.
Yeah, Long, could you say like what's for tomorrow? Like what shall we come up prepared with? And
so the problem, I'm very clear what's going to happen is, again, we'll not have, because people are in day jobs, they can't update document, they can't update. So I will do sessions every day, and with a single thing that as soon as possible people get into contributor mode, and whatever is required, I'll do that. But I'll do sessions every day at 8 p.m.
yeah, cool. So since we are recording it, we can put it, and next time anyone asks beginner question, we could just point out like where to look at.
Yeah.
Sure. I'm leaving that all to you, because you really don't know the power of I mean, in connection with this headache of HTTP, HTTPS, gRPC, traffic from outside the cluster to inside the cluster. In this whole scenario, Ingress controller and all of that, the Ingress object itself, you still you just a few days away from getting the essence of it. So I bring content. I can bring content, posting to YouTube and all that. Great. Right now, I don't have bandwidth for all that. Okay, it's a convention. It's a pattern that whenever things are done, they're recorded and posted and all that. It is good, bad. I'm unable to focus as of this moment for a few because I have to write a document now, and I'm not able to write, and I want to actually work on two issues that are probably in my kitty, but besides the document, I'm not able to, because we have a bigger problem of too much load. And I think that if we have more help, if more people are at least triaging, then it will help. So anything that works, you guys do YouTubing and all that, and actually it's so much joy that if I can see a message, in Slack, and I can point to one of you guys saying, hey guys, we talked about this during Zoom sessions. You can respond to this person and ask him for the commands. I want to get to that first. Okay.
Yeah, cool, got it.
Okay.
Yeah, okay then.
So again, this is my request is, I have this issue that silent listening basically dries up the content or thought process. So unmute yourself and keep talking. Talk, and give feedback. Give me at least assurance what's going on in your heads and your plans, so I can alter things, what I present, what I show. I can probably bring new things. Because right now I can't go to the committers and say, hey, can you give us a code walkthrough, or can you give us something? Because we are not energy level wise or environment level wise, we are not there yet in terms of feedback. Forget knowledge will come in its own time, but feedback, engagement wise, we need that. So unmute yourself and talk. Anything?
I believe it was really good session. Long, I guess all of us can go back and do due diligence and come back prepared for tomorrow's session.
Awesome. That is nice to hear. Anybody else? Yusuf, you don't talk at all.
I just want to say that I'll be consistent. I actually am not saying much because I have to do my own research. So I'll watch the recording again and again, and we'll try to practice as much as I can until I actually get the concept clear.
So what is going on right now? How much did you get? How much did you not get? Or what is it that you get? What is it that you are taking home today from these sessions?
So I'm actually like planning to get the concept clear with like HTTP working, like as you mentioned about Postman. So we'll try to experiment with that, and we'll report like if I come across any issues or something.
Okay. So are you able to create a Minikube cluster on your laptop, or do you have a cluster on the cloud somewhere that you can play with?
Yeah. I mean, I'm using Mini.
Yeah.
Sorry?
Sorry to overtake. Just a quick question: is there any requirement on using Minikube only, or can we use any cluster?
You can use anything you want. I'm just saying Minikube is the first thing that came to your mind for iteration. You don't have to wait for type a command, and waiting is not. You can use any cluster, but just don't use Docker driver because it's complicated. You can use Docker driver if you have the know-how about it. Then we can discuss that, but it'll be one-on-one discussion. It will not be in meeting because other people will not know how to mess with Docker driver clusters, Minikube, kind, and all that. But whatever works for you is fine. I just want to get you guys into that shape where you can talk to users. Not solve issues, just talk. Ask for information. You guys understand what I'm talking about, right?
Yeah.
Yeah.
I think I just need some time and then I'll surely like sync up along with it.
Okay. Anubhav, anything?
I will like in a few days, like next few days, I will try to like get in these things and understand. And if I get any doubt, I will, of course, like we have daily sessions, so I will ask in them, or I will ask on Slack, or I will DM you.
Okay, Sachin?
Yeah, I learned a lot of things today and looking forward to learn more. Like most of the commands I was knowing, and I'm going to learn more from the talk that you have shared with me, other people.
Okay, Shubham?
Also, the last part where you showed like demo thing, that was a little overwhelming for me. So I may take some time to like get comfortable with those.
Yeah, no problem. It's just
Yeah.
for you to see something happening. So it's not.
Yeah, thanks.
Don't get overwhelmed. Okay, Shubham?
Like yeah, even I learned a lot like about the basic was the working of Kubernetes, and then like I had a bit of difficulty following the kubectl commands. So like I think that is because of my lack of experience with like I haven't played much with Minikube, so maybe that is why. So I would like to practice maybe on Katacoda or somewhere like that. First to get to know more about the commands maybe right now.
Okay. So my apologies why I picked so much time, late time, and now again one by one I'm calling out name is a very simple reason. I'm hoping you guys form communities of yourself, like instead of individuals, just the learning process. Once you guys are in that stage where you can ask questions, ask commands, outputs for the state of you complaining users cluster, and then try to and reproduce using the whatever he describes, reproduce until you get to that, you will have to do joint learning, because individually it's going to take at least 2 months or 3 months, because it takes at least 8 months to get to grips with Kubernetes, at least. Okay, that's my even for the smartest people, it takes 8 months at least, to be effective. And only way I found is group learning. So that's what I was I'm gunning for. You guys talk to each other, either asynchronously you can talk, because Raj said he's in UK. You guys either asynchronously or synchronously, and you're first time meeting each other. But so that thing is going to take some time. But if you can like put it in overdrive of group learning, within a week or within 10 days, we can achieve that part where you ask command outputs from users on GitHub as well as on Slack.
Yeah, definitely.
Yeah, sounds good.
Okay. Yeah. All right. I'm done. If nothing else, we can close.
Yeah, I think
Catch up tomorrow then.
we
Okay.
can stop the recording.
Yeah.
Yeah.